Hi, and welcome to the second lesson for week 1, laws of exponents. I know that, again, this is a lot of review of things that you guys may already know. Um, so I am going to go through it kind of quickly, but again, it is a video, so feel free to always stop and pause and do what you need to do, okay? So what are exponents used for? A lot of times exponents are used to do calculations with really big numbers. So say we were talking about like the distance from Earth to Pluto, or really small numbers. So we're talking about something like microscopic size. All right, so dive right into it. So exponents are, they're also called powers, are used to indicate repeated multiplication. So for example, instead of saying 6 times 6 times 6 times 6 times 6, we're going to say 6 to the fifth power. 6 would be called our base, and 5 would be called the exponent or power. So by definition, if x is a real number, meaning basically any number you guys could think of, and n is a positive integer, so it is not a fractional number, then x to the n is equal to x times itself in number of times. So we would read that as x to the nth power. All right, so our first example, we're going to use the product rule. So here we have some real numbers, a, m, and n. So if we if we multiply numbers with the same bases, then we are adding the exponents. So let me go ahead and show this to you guys with numbers. So say we made this a to the third, a to the second. So I'm going to draw this out. So it could have actually been, instead of a to the third, a times a times a, and then a squared would have been times a, because remember this number in the exponent is telling us how many times I'm multiplying a times itself. So here I can obviously see, oh, that's going to give me a to the fifth power. So the cool thing is I could have just used the rule a to the third plus 2. And then that would have still given me a to the fifth. So it's kind of a cool, shortcut if you don't want to sit there and write those out over and over. And then down here, I don't know if you guys can see where it says exponents. So say we had numbers for our base, 3 to the third times 3 to the fourth would be 3 to the 2 plus 4, which is 3 to the 6. So in other words, when you're multiplying, you have the same base, then add the exponents and leave the base alone. Something to help you kind of remember what to do there. If you're multiplying, that multiplication symbol kind of looks like a twisted plus sign. So maybe that might help. Okay, again, going right into it. Here's our quotient rule. So we have a to the m over a to the n is equal to a to the m minus n. So again, I'm going to show you how this works. So a to the third over a squared. Say I expanded these exponents, so that would actually be a times a over a times a. So if you remember, when you divide a number times itself, you get 1. So every time I have a over a, those are becoming 1s. So all I'm left with is a. Okay, so using my rule, a to the third over a squared would be a to the third minus 2. And that's going to give me a to the 1, which is just a. Okay, so in other words, when you're dividing and the numbers have the same base, then subtract and leave the base alone. Another way to kind of think about it, your division bar kind of looks like a subtraction subtraction sign, right? Okay. Here we are. Negative exponent rule. So we've got a to the negative n is equal to 1 over a to the n. This one is sometimes tricky because we don't think about fractions like this. But so you see here we've got 3 to the negative 2 power. So that is actually the same thing as 1 over 3 squared. So if I multiplied out 3 times 3, then I'm going to get 9. So the second example, we have the negative exponent in the denominator. So this would mean I'm actually dividing that, or sorry, it's like 1 over 3 to the negative 2. Again, that's kind of confusing. So this is kind of how I think about it. Think of a negative exponent as being like unhappy. Say we live in an apartment building, so technically that would be over 1. Here's my building. So right now, 3 to the negative 2 is like upstairs, and 1 is downstairs, right? Here's my door. So in order to make this tenant happy, he's not happy upstairs, so I'm going to bring him downstairs. So what's going to happen is that empty space is just going to have 1. And now when I bring him downstairs, oh, he's happy, right? So kind of the same thing here, like 3 to negative 2 is unhappy downstairs, so I'm going to move him upstairs. So now he is completely content upstairs. And remember, when you don't have a number sitting in the fraction, whether it's above or below, then you're just going to fill it in with a 1. So 3 squared is 3 over 1, which would give me 9. 9 over 1. We don't usually leave our numbers like that, so that's where we're just getting 9. Okay, so down here, basically, if you see a negative, either sink it into the denominator or bring it up into the exponent. And when you change it, it's going to make that exponent happy and positive. All right. Zero rule. This one is just super nice. Anything raised to the 0 power is just going to be 1. So say I even had some kind of crazy example, which I'm not going to give you guys, but anything raised to the 0 power would give us 1. Why? Go ahead and show you. Oh, there we go. Sorry. So 1, we said earlier, anything divided by itself will give us 1, meaning it has to have the same power. So say I used that quotient rule right here. So I would have same base and the same powers. Well, that's going to give me 0. So here's my a to the 0, and that's always going to give me 1. All right. Okay, so our power rule, this one is actually kind of nice too, saves you a lot of time. So basically, if I have something raised to a power, all I'm doing is multiplying. Um, it's different than our product rule because in a product rule, we're adding the exponents, but here you're multiplying. And I think about power, like multiplication is a more powerful operation than addition. So raising power to power, I'm going to use the more powerful operation, which is multiplication. Okay, another way of thinking about this, I could expand it just like we did before. So that is telling me that 3 squared is being multiplied by itself 4 times. So every time I'm using a law of exponent, I'm saving myself from doing a lot of writing, which is great. So here, it's the same thing. 2, 2, 2 more is going to give me 3 multiplied together 8 times. All right. Here's our quotient rule. So by definition, power of a quotient rule. So by definition, basically everything inside the parentheses is going to get the exponent from the outside. So here I see I have 3 to the 4th inside. Right now, those are technically raised to the 1 power. So I am multiplying 2 times 1, and down here 2 times 1 again. So I'm getting 3 squared over 4 squared, which is 9 over 16. Just remember that whatever you do to the top, you do it to the bottom. Those parentheses are telling me that the exponent is going to go to everything inside of it. Okay, and then here we have our rational exponents. So when you have a square root, we normally don't think about it this way either, but technically, like say I had the square root of 3. I could rewrite that as 3 as my base to the 1/2 power. So 1 is the power. So technically inside, that was 3 to the 1, and 2 is the root. So we don't usually write the 2 outside of a square root, but the whole thing about square root is that we're looking for basically how many times that number is multiplied by itself, and it's only groups of 2's. So in other words, the exponent on the outside goes to everything on the inside of the parentheses. Another way of remembering this, so again, powers are usually things that are above us, and roots, like trees, roots grow below us. So I kind of think about it like this. There's my power. This is a tree root, not an artist. There you are. Okay. All right. So let's get right into this. These are going to be examples. I'm going to do quite a few examples so you guys have some in your homework. Um, so stop and pause as you need to. Do them on your own and then check yourself, because I know this is going to be a little bit lengthy, okay? All right, so first of all, we don't want to leave negative exponents in our final answers. Um, there are other ways of always getting your answer. So if you work it out on your own, you're like, hey, I didn't do that as my first step. That's okay. We will still end up getting to the same final answer. Um, and so we're going to use our laws of exponents. And I'm not going to put equal signs in the expression unless it's there to start with. That's just a little disclaimer. All right, so our first one, we always check outside of the parentheses first. I don't have anything there. So this is just straight multiplication. What I need to do is start grouping those terms with the same bases together. So you notice how I have -5 and 2? I am going to multiply these together. These are my coefficients. They're not going to fall into the same rules as the rules of exponents. We're just going to multiply them like regular numbers. Then I'm going to group the x's together. So we have x to the third times x to the -4th power. And then I'm going to group my y's together. So y to the -8 times y to the -2. This helps my eyes see, all right, so I can multiply -5 times 2 and get -10. And then right here, what I'm going to do is use my product rule, which tells me that I can just make this as x to the third, and that is going to be plus -4. I'm going to come back to that. And then y, keep my base, I can use the product rule again. So -8 plus -2, and then let's just go through and simplify. So my coefficient is still -10. 3 plus -4 is going to give me -1. Whoops. I don't want that to completely go away. Sorry. That's going to be x to -1. Pretend that's not there. Okay, then our next group, y, -8 plus -2 is going to give me -10. All right, remember when we said we don't want to leave negative exponents. So what I'm going to have to do here is to move everything around. So with coefficients, these do not fall into those exponent rules, right? So -10 is completely content where he is, upstairs. X to -1, though, that's like negative x to -1 over 1. He is not happy upstairs. So we're going to move him down. That's going to be x to the 1. We don't usually write exponents of 1, so it's just x. And then again, this is like y to the negative 10 over 1. He is not happy upstairs. We're going to move him downstairs, and now that's going to be y to the positive 10. That's my final answer. Okay, a couple more examples here. Y to the 13th power over y to the 40th. I don't want to sit there and write out that many y's, so I'm going to use my quotient rule. So this is going to just basically become y to the 13th power minus 40. It's okay to have a negative exponent, just not in my final answer. So again, this is technically over 1. Y is not happy up there. We're going to move him downstairs, and we're going to use 1 as our placeholder. So this is my final answer. Number 3. I love these. So again, we say anything to the 0 power is going to give us just 1. That's it. Nothing to do on number 3. Number 4. Be careful with your coefficients. I know sometimes we get so lost in all of those rules. We are not going to subtract 28 negative 14. That is just like this, 28 divided by negative 14. Okay, so what I'm going to do first is split these up into like their own little fractions, and then I'm going to simplify it. So I'm going to split up all the x's, and I'm going to split up all the y's, just like that. So now I can divide here. So 28 divided by negative 14 will leave me with negative 2. X to the third over x squared. So we can just use our law of exponents. Remember, we said we subtract those, okay? And then y to the 5th minus 8. So I'm subtracting the power in the numerator minus the power in the denominator. Okay, so I'm going to continue this. 3 minus 2 leaves me with 1, so that one is done. Y, 5 minus 8 gives me negative 3. Uh-oh, I've got that negative exponent. So that one is going to have to move downstairs and become positive. There's my final answer. Negative 2x divided by y to the 3rd power. That one could have been expanded if you really wanted to, like if those laws are just not making sense quite yet, you can always write those out and then start canceling. And by canceling, remember, we mean that means it's becoming 1, so they don't just vanish and disappear. So 1, 2, 3, 4, 5, 6, 7, there we go, 8. And I can see how we end up with y to the 3rd in the denominator. Okay, number 5, we do need to simplify in the parentheses if we can before we make it more complicated and bring in that exponent of 2. So starting out by simplifying 6 divided by 4, those are both divisible by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So far inside of my parentheses, I have 3 over 2. The a's, so I have a squared over a, which is going to leave me with a to the 2 minus 1, which is just a. That is in the numerator. Then I have b to the 4th over b cubed. Again, that's just 4 minus 3, so that leaves me with b in the numerator. All right, now I can square everything. So our power rule, when we were talking about quotients, we said everything gets the power. Okay, so it's like an Oprah show. Everybody's getting a car here, except they're all getting an exponent. So going to generously give that squared to the 3, also a squared, also b squared, and then in the denominator, don't want to forget about 2, and make sure I square that as well. So 3 squared will give me 9. A squared is just a squared, and then b squared all over 2 squared, which is 4. Now this is my simplified answer. Number 6, look inside the parentheses to see if I can simplify, and I cannot. What I can do is I know that everything's being raised to a negative exponent, so I might go ahead and just move all of that to the denominator. And I'm going to leave it exactly as it is because that's technically how it should be written. I can simplify that c to the 0 though. I don't really need it because it just becomes a 1. And what happens here is that 3 is now positive 3. So I've got to give the exponent to everything in the parentheses now. So that's going to be 2 to the third times a to the third to the third. Because remember, I'm giving this exponent to everything inside the parentheses. It's like distributive property, but with exponents. And then you've got b to the negative 4 to the third power. All right, so I'm going to take care of simplifying. 2 to the third is 2 times 2 times 2, which is 8. A, and then we've got power to a power, so I multiply those and get a to the ninth. And then when I multiply negative 4 times 3, I end up with b to the negative 12. So there's only one unhappy tenant here, and that is b. So he's going to move upstairs, become positive, nice and happy, and then 8, a to the 9 are all going to stay downstairs. That's my final answer. Oh, and if you're wondering what happened to that 1, remember a coefficient of 1, it usually just doesn't show up. It's everywhere. We're multiplying by 1 everywhere, just like we're adding 0 everywhere, but we just don't write it. Okay, and then our final one, I believe, nope, there's 2 more. Number 7, again, I like to split these up just to help my eyes a little bit. So my coefficients are 3 and 6. X to negative 2 over x cubed times y to the third over y to the negative fifth times z to the negative 1 over z to the negative 2. So take this one bite at a time. 3 over 6 is going to leave me with 1/2. X to negative 2 over 3, so this is going to be like x to negative 2 minus 3, which would be x to the negative fifth. This y to the third over y negative fifth, using my law, y to the third minus, negative 5. So when you have that funky minus and negative, I think of this as just a big ugly plus sign. So that's just going to be y to the 8th. And we talked about that more in the order of operations video. So if you're like, big ugly plus sign, that's not mathematical, I need more information, then watch that video and I will go into more detail. And then our last little fraction here, so we have z to the negative 1, so that's going to be the same as z to the negative 1 minus negative 2. I've got that big ugly plus sign again. So that's really like negative 1 plus 2, which is just 1. Now I'm going to sort everything out into fraction. So the 1/2 is going to be split up 2 in the denominator and 1 in the numerator. Y to the negative fifth, or sorry, x to the negative fifth, he's unhappy upstairs, he's going to move down. Y to the 8th, y is completely content, leave him upstairs, and so is z, z to the 1. I'm going to clean up these 1's because we don't need that coefficient. We also don't need the power of 1, so make it as clean as I can. And there's my final answer. Okay, I believe we have one more, and I'm going to finish the rest of the notes in a separate video. So let's just finish here, and then I will post another video about simplifying our radicals. So here, I notice I have a negative exponent. I'm not going to put everything over or under 1 because that's just going to make it look crazier. What I am going to do is start simplifying inside of the parentheses. So start with my coefficients 5 and 2. I can't really simplify. What I can do is simplify the x's. So what I've got, still got 5 in the numerator, 2 in the denominator. I have x to the 1 using my quotient rule. That would be -4. So I end up with x to the -3. So if you're wondering, where does that go? That is going to actually, I'm going to just leave it up here, and then we will check that again here in a minute. Then you've got y to the -3 over y. So y to -3 minus 1. Don't forget, when there's not an exponent, there's always an invisible 1 there. So that might help to write that in. So we have -3 minus 1, which is going to give me y to the -4th. So I'm going to put that one there. And then we have just z to the -3rd power. All of this still raised to the -2. Okay, so now I'm going to start switcheroo with everything. So 5 over 2. Our coefficients are good. X is unhappy, so he's going to move downstairs. Y is also unhappy. Z is unhappy. So we're going to switch them around. Okay. Now I need to bring everything to the -2 power. Uh-oh, this is going to make us have to switch again. So I'm going to raise 5 to the -2. I'm going to raise z, and I'm going to use the power rule. Okay. Then 2 to -2, x to the 3rd, multiply -2, and y to the 4th, and -2. So this gets rid of my big parentheses. Now what I need to do is to multiply. So 5 to -2 is the same thing as 1 over 25. So that would actually be, if you're not sure where I'm getting that, 1 over 5 squared. So I'm just going to go ahead and square that out and move it at the same time. Same thing here. This is like 1 over 2 squared. So that's going to be 4, but it is in the denominator. Okay, so it's going to have to switch all the way back to the numerator. All right, when I multiply this x to the 3 times -2, I get x to the -6. That is unhappy, so he's going to move upstairs. Y to 4 minus 2, so y to -8. Unhappy downstairs, he's going to move up. And then you've got z to the 3 times -2, so that's going to be z to -6. That was in the numerator, but I'm going to drop it down to the denominator to make the exponent positive. All right, part 2 of this will be posted in a separate, shorter video.